Hello students, in today's video we are going to study about the chapter force and pressure. So in this video we are going to study about what is force, their characteristics and what are the major types of forces and their examples. So let's get started. So the chapter title is force and pressure. In this chapter we will be seeing what is force, what are the characteristics of force, types of forces, pressure exerted by the fluid and atmospheric pressure. Now let us know what is force. Force means the push or pull applied to an object. Means if someone is dragging someone, if someone is pushing something, then there at that person is applying some kind of force, and that force is capable of either changing the state of motion of the object or either it can change the shape of the object. For first one, let us know the state of motion of an object, how the force can change the state of motion of an object. Now as you can see in the figure 1, the boy is rolling a ring with the help of the stick. Here the ring is changing its position because the boy is applying some kind of force upon it. And let us know the shape of the object, how the shape of the object can be changed with the application of force. In the second figure, as you can see, first one, if you will hold the rubber band without applying any force, it will be of certain length, but if you will try to stretch it, then it will be expanded. Similarly, if you will try to compress one sponge or a piece of sponge, then it will be squeezed. As soon as you release your hand, it will regain its shape. Same thing happens in case of the spring. If you will compress it, then it will be of shorter length, and if you will release it, it will be expanded. Next, come to the characteristics of forces. When two forces act in the same direction, the net resultant force of an object is the sum of these two forces. For example, let us consider two forces F1 and F2, which are acting in the same direction upon an object. Then the net force which will be applied upon the object will be the sum of these two forces. For example, we will see in the diagram. First diagram, you can see two people are pushing the wooden box in the same direction. So the net force applied upon that object is the sum of these two forces. But what will happen if two opposite forces are acting upon an object? For example, in the second figure, you can see two people are pulling the box towards them. Means here both the people are trying to pull the wooden object towards them. In this case, the net resultant force will be the difference of the two forces. Means in mathematically we can say here the net force acting upon this object is equal to F1 minus F2 or F2 minus F1. But now the question arises, what will happen if F1 is equal to F2? Means both the person are applying same amount of force upon that object but in opposite direction. In this case, the net force F will be is equal to F1 minus F2 or F2 minus F1 is equal to 0. This force is the vector quantity, means it always has a definite direction. What is the meaning of vector quantity? Vector quantity means the object which is having both direction and magnitude. Force is always having a defined magnitude and also a particular direction. Let us know about types of forces. So force is broadly divided into two parts. One is contact force, another one is non-contact force. Again, contact force is again divided into muscular force, frictional force and air drag. Non-contact force is divided into magnetic force, electrostatic force and gravitational force. These are some vital examples of contact force and non-contact force. Then contact force means where the two interacting objects, when they are interacting directly, we are saying that the force existing between them is a contact force, but when they are not interacting directly, then the force which is existing between them is a non-contact force. For example, muscular force. Muscular force means when we are pushing or pulling someone or dragging something, we are using our muscle to apply some kind of forces upon those objects. There we are directly involving in the activity of dragging, pushing, pulling. Means here we are saying that this is the contact force, means we are directly involved with that object, so this is muscular force. Frictional force, force means suppose you are dragging the box upon the marble floor, or you are dragging upon some rough surface, then the frictional force is opposing the motion of the object. Here this opposition force or resistant force which is opposing the motion of that object, we are calling that is the frictional force. Here is also, this is also an example of contact force, because here both the object and the surface are directly in contact with them. Then air drag, suppose one aeroplane is moving through the air, it is piercing through the air. No, that means it is the resistant force which is opposing the motion of the aeroplane is known as air drag, or you can simply say it is the air friction. Then magnetic force. Magnetic force means, as I told you, the attraction or repulsion between two magnets is called the magnetic force. Then electrostatic force means basically this kind of force exists between the charged particles, means like electrons, protons, like those two charged particles, positive and negative charged particles. You can find both positive means attractive force of force between them, or repulsive force between them. Then gravitational force. Gravitational force, it is always an attractive force, and gravitational force means suppose I will throw a ball and it will come back to the earth's surface. Why? Because due to the gravitational pull of the earth, it is dragging the ball towards it. So here are some pictures. In the first picture, muscular force is existing. In the third picture, frictional force, and in the fourth picture, air drag is existing. And here are some more sets of picture. In the first one, you can say magnetic force is existing. Second one, electrostatic force, and the last one is gravitational force. Next, let us come to pressure. Pressure means the force applied per unit area. As you can see in the diagram, mathematically you can write pressure as force divided by area, or you can modify the formula to write it as force divided by pressure. That will give you area, or you can write force is equal to area into pressure. To easily remember this, you can just simply draw a triangle. Upon this you can part into three parts and write F stands for force, A stands for area, and P stands for pressure, and you can cross multiply them to get the formula force is equal to area into pressure, or the pressure formula pressure is equal to force by area. The pressure exerted by an object always depends upon its surface area. If the surface is small, the amount of pressure applied is large, and vice versa. Why? Because from the formula itself it is clear that the pressure is directly proportional to force and inversely proportional to the area. You can see in the second figure here also, here are two objects where one is having the surface where one's surface area is larger and one's surface area is smaller, and you can compare their pressures. The SI unit of pressure is Pascal, or you can say that is Newton per meter square, and pressure is always dependent upon the surface area. To explain this, let us see the next diagram. Here you can see you are trying to pierce one person with the help of your finger, but it will be difficult. Means you can pierce them or pierce through their skin by you just using your finger. But in the second part, you can see you can easily pierce through their skin by using a syringe, because the surface area of the needle is very less. The tip of the needle is having very less surface area. That is why it is easy. It can easily pierce through the skin. Now we will study about pressure exerted by the fluids. What are the fluid? First of all, we will know what is the meaning of fluid. Fluid means the liquid and gases. Liquid and gases are commonly called fluid. Fluid means those substances which flow, which can flow means air can flow, that is a gas, and also liquid like oil, water, they can flow, they are also coming under this fluid. So this fluid also exerts pressure on the walls of the container. Suppose I will carry a pot of water, there at the waters are exerting the force on the walls of the container. Also, if I will trap some kind of air inside a polythene or inside a jar, then there also the gases will be exerting pressure. In this both the examples I am showing you, here you can see, here in a glass beaker I have filled some kind of water, and here also some in a plastic bag also some kind of waters are filled. And if I will make some kind of hole, the water will start trickle through these holes. Why? Because this water which is kept inside this bag or in this jar are exerting pressure on the walls of this container. When I am making some kind of hole, they are just what trying to rushing out of this jar or polythene, because they are inside that they were kept in high pressure. Now they are whenever they are getting a small hole, they are trying to come out of it. Then here you can see, here suppose this is a square, the container where the gas molecules are moving here and there in a random motion, and you will see the gas molecule particularly they are bombarding in the walls of the container, and similarly they are also exerting pressure on the wall. Now we will study about atmospheric pressure. Atmospheric pressure means it is the pressure exerted by our atmosphere. Suppose a layer of gases is present around the Earth's surface, the air present in the atmosphere exerts a pressure on the Earth, which is called atmospheric pressure. For example, the value of atmospheric pressure at sea level is 1,1325 Pascal. The atmospheric pressure keeps on changing as we move towards the Earth's surface. As you can see in the figure, here you will see that the atmospheric pressure depends upon the air column which will be present over someone's head. As you can see, the person who is standing below the mountain, the air column which will be present upon his head is more, means he is experiencing more atmospheric pressure, but the person who is standing at the top of the mountain is experiencing less pressure. Why? Because the air column which will be present upon his head is less. So we can say that one interesting example, we can say that in higher altitudes where the atmospheric pressure is low as compared to that of the Earth's surface, there the nose bleeding occurs. Hope you all like this video. If you have any doubt or any queries regarding this, you can inbox me. Thank you.